Welcome all. Good evening for friends in India and good morning and good afternoon for friends globally. My introduction has already been done. One of the things which I'm doing right now as a Chief Technology and Innovation Officer at Capgemini, data-driven innovation. How can we bring more innovation for our client? We're using data. A team of 25,000 employees within the group, and we're focusing on only data. In my past, as I mentioned, right, I worked for 13 years at Microsoft. Without even asking, right, I can guarantee that each one of you are using the product which I have built. Either you're using Outlook or you're using Geo. Definitely, I worked on both of them. Okay, large scale engineering, things which can be done are used by 300, 400, 500 million users. Those kind of scale, how does that work? Majority of them has to be powered by data, and that was my experience working at Microsoft initially with Bill Gates initially, and then towards the end it was with Satya Nadella when he was a vice president. I had the honor to write Microsoft first ever AI algorithm, and 11 years back when I came back to India, I decided to do teaching and faculty at multiple places, including IIT, IIM, BITS Pilani, and also at other B schools and all. A professional coach and guide, and there's 2 books which I published, and the 3rd book I'm writing. In the journey, one of the elements which I found very, very useful was, see, 27 years back, right, there was not much of internet. Yes, there was something called internet, but very, very flaky, hardly used to work and so on. At that time, I was working for companies and I was saying, how can we put rules so that we can do some automation, and the rules were based on the data. Okay. And then after that, I joined Microsoft and all, and that is the place I talked about some of the AI part, which I'll give you some examples. But over a period of time, even at Microsoft, right, when Microsoft started getting huge competition with Google, 2006, that's why we said, how do we compete with analytics? How analytics become a differentiating factor? So as a data scientist, I'll be talking about a day in the life, what it goes through that. But the more important part is, do we have the business? Do we have the goal? What are we going to work on those? 2011, came back to India, and that's the time working for other companies and all. And then I realized the focus should be more on the data culture. So the whole element of data, right? And now at Capgemini, focusing on future of data, how organization can build themselves on those. So with this, that's about my whole career journey. Now, talking about this, I'll let you spend some few seconds on this slide. One of the important part I would encourage you is data science is new. A lot of things are happening in the industry. A lot of things are there on the internet. Take advice from the right people. 1998, I know some of you were not born at that time. 1998, when I was working for a company, one of my friend's brother got a job in Intel in US. I said, wow, what it takes to get a job in Intel or Microsoft? Google, Facebook, there was no Google and Facebook at the time. He said, Mukesh, forget it. You can never get into Microsoft or Intel. I said, why not? First of all, you are not done masters. You are not from a premium institute. Your scores are not good. Your English is poor. He had all the reasons that I could not join Microsoft. Mental block. I wouldn't thought I can never get into Microsoft. But come September 1998, randomly surfing the website, found a place, applied for a job in US. Click. Which company you want to apply? Of course, Microsoft. Why should I reject Microsoft? Let Microsoft reject me. I did that part and I got selected. If I had listened to my friend, I would have never got a job in Microsoft. So do not let your mind clutter or get the negativity just because your friend told you so. Take the advice from the industry experts, not the 2, 3, 5 years experience more than you, something who has substantial experience, been there, done that. Now, why are you talking about data science? Why are you talking about so much right now on data science? One thing I would like to highlight, we all have choice. Let's say you're leaving from home, going to the railway station or the airport. It shows you open Uber or Ola, and it shows you like this circle. How many seconds are you going to wait? 7.2 seconds. 7.2 seconds is the threshold for people in India to be able to wait for an app to respond. 4.4 seconds in US and 2.1 seconds in Japan. That's the threshold we have to wait. But what would you do after that? You will kill the application and go to Uber. Vice versa. Zomato, Swiggy, Amazon, Flipkart, you all have choice at each and every element. With the choice, what does that mean? We want anytime, anywhere, on any device, otherwise we are going to switch over. That's the expectation. Now, when you switch over, you don't mean that you cancel your Uber account and go to Ola. No. On that transaction, you switch over because it's not working. So you just move on, right? The purpose of this application is important for them to become that how can I understand the usage and then innovate? And this is the element which a lot of data scientists miss out on. The purpose of the data science is not to just write algorithms and which they do very well, but also to solve a business problem. Okay, and that's why there's a growing need of data scientists across the globe. And this is the right time to get into those and ride the wave to get the value, and then of course help the organization compete on analytics. Some of you may know this slide. This is the 18-year-old slide. A scientist named Cano suggested that the expectations in the industry for any product changes over a period of time. There are 4 categories of anything you have. Any product, pick any product of your choice today. There'll be something which is must have. You type and then you send and you get it. It could be WhatsApp, it could be a mobile phone, it could be a laptop, it could be anything. And there are something which is more. You like it and you want more. More memory, more RAM, more cameras. And then a delight. Wow. 18 years back, doing an email on the phone was wow. The phone model, you see? Check with your parents, or check if you were there, you might have seen this phone model. Wow, if you can do email on the phone. Now we don't even ask for that. We say, hey, the phone should have it automatically. And then of course, dissatisfied, yeah, the charging takes longer, but that's okay. What Cano suggested is all these 3 part, the dissatisfier and the delight becomes must have. So all the 3 merge to the 4th one every few days, weeks, months, and years. And then, which means the delight need to continuously grow and things become must have, which we no longer have an option to say, yeah, it will be good to have that. No, you need to have that. Right? And that's what the thing is, which means if you don't understand, if you wait for client to tell you what they need, you will be obsolete. And that's what happened with 50% of Fortune 100 companies. They no longer exist because that was not understood by them. Now, if you look at the industries, each of these industry, if you plot, the high-tech industry is on the top in terms of the intensity and top in terms of the digital the transformation intensity and the digital intensity. Yes, you might see a little bit of telecom and travel could be slightly higher than that because they are using this every day. But then are they able to transform and all? It's a mixed bag. The reason I'm bringing this slide is you could be in one of these domains. I always encourage people not to go directly in high-tech. If you're already high-tech, good. But if you go backward, you have more chance to grow faster. Which means if you go to banking, retail, consumer product, manufacturing, pharmaceutical, you have a lot more opportunity to grow faster because each of these industry are now going to start implementing big time AI and analytics. High-tech has already been doing this, right? So one element you need to understand is the data scientist job is what? Data scientist job is to enable decision. But before that, you need to also understand how a decision taken, not just by flipping the coin, right? I call the word hippo. Highest individual paid person's opinion. It's interesting. Normally, if you see on the table of the people, decisions are taken. When decisions are taken, the highest paid person, oh, we should do it this way because I think so. We should do it that way because I think so. So in this data hour, think about yourself. Think about the decision people have made. When I was at Microsoft, when I was at the multiple places, if I see somebody taking decision without any data, I used to have this small hippopotamus, just keep one step ahead. The important part to notice here is if you do not use data for decision making, it's just an opinion and it may or may not be even good or worth it. At the same time, you may not have enough data. So on those cases, yes, your experience matters. So let me give some examples, then I'll talk about the whole journey, about what a day in a life looks like for a data scientist. These examples are important for you to know that what all things which you're using it was powered by data at some point. Some of them 10 years back, some of them 20 years back, some of them 5 years back. You should know about those so that you can start appreciating those and then use it. use it in your day-to-day examples. Have you seen this button? Send error report. 1999, when I came up with this idea, my manager told me, Mukesh, that's the most pathetic idea I ever heard. Idea. The first part is idea. It's okay when people tell you that you are a crazy person. And in fact, they should, because nobody has seen the idea. How can it be validated? But once I started doing, I started collecting data. So you press the button, it captures the data and say, my manager was right. He said nobody will click the button. He was right, partially. 1.4% people clicked on the button, which is enough, right? 1.4% out of millions of people who use that. So first one was idea. Second one is you need data. And the data was collected. And then we were able to find the value that, yes, we now know why it was crashing. It was because of code, or was it because of scenario? Was it because of data, or the machine configuration or a virus on your computer? That's why it was crashing continuously. And once we know those parts, we were able to create a model, and then we can able to deploy some of the updates after that. Important to note that part as well. Powered by data. Now look at this one. Now this is the situation. We don't even have a problem. Exactly 6 years from now, September 2016, you know what happened, right? Jio was launched. First time launch, new towers. How do we understand whether people are getting the service or not? The call drop. The bars are not able to reach you. All the challenges. At that time, we used some of the machine learning techniques as a data scientist. We were able to implement, when I was at Jio, we were able to implement some of the algorithm which were used during this time to be able to see why somebody is not getting a signal, or what is the number of bars at that moment of time. And we were able to capture those and understand those and make those updates on a frequent basis. You might have observed every few days, weeks, and months, the network quality was improving in those areas where it was call drop was happening. You never called them and told, hey, Geo, my call is getting dropped. No. But the automatic data collection is very, very important. Use clustering model, find those out, take some action, and you're ready. Now, this is my favorite. Bill Gates used to get 16,000 junk email per day. 1999, yes. Now, when you get 10 junk email, you feel awkward, you feel upset, right? Now, imagine Bill Gates getting this many junk. So I was junior most person in the team, and I raised my hand and again I do it, and my manager would no, you are not doing this. Now think about it. Are you going to read a junk email for more than 5 seconds? Are you going to delete an important email in less than 3 seconds? The answer was no. So this idea came up that, instead of just focusing on the keyword, junk words and everything, can we consider capturing the information which is available, which is the behavior of a person at that moment of time, and see if that can be used. And it worked. It worked very well to be able to classify that, yeah, these are the email I've deleted faster, these are the email I've read fully. And then based on that, I will create a model, update the model. What are the junk for me? What are not junk for me? 94% accuracy we were able to get for Bill Gates in that period. And that's how the junk email was burned. You might have observed, you get a lot less junk in Outlook compared to Gmail. Okay. This is the algorithm in action. Now, as a data scientist, what are the things involved in the day in the life to build this part? Think about it. The first one is idea. Always start with an idea. Then you need to collect data. So you put something so that the data start collecting. Data doesn't come automatically. You have to collect them. And that is the important part. We'll talk in a few more minutes now. And this is the interesting one. Have you ever asked yourself why the color of search links, Bing or Google or something, by default, if you are not changing anything, by default, these are all green, red, or blue color, right? I was curious. Now the challenge a lot of us have, the way we are born and brought up, the culture we live in and all, we normally accept whatever is told us without we challenging them. How many of us challenge them? In fact, I was born and brought up knowing that the apple color is always red. And I was very happy about that until I found out that apple could be of other different colors also. Right? Same thing here. Curiously asked this question. Somebody gave me the answer. The blue color is the color of trust. Blue color signifies data. And that's why the search link shows that, hey, you can trust this link, and people click on the link because it's all about trust. Very convincing. Maybe he's right. And he was right. But the second question, why this shade of blue? He didn't have an answer. He said, Mukesh, what is in your mind? I said, in Hindi, there's a phrase, there's an advertisement from Asian Paint, Mera Wala Blue, my favorite shade of blue. So it was not just my favorite shade because I don't want to be hippo, but I want to was curious to know, is there any science behind selecting a particular shade of blue? And you might say, oh, that's so trivial. Yeah, even I thought that was so trivial. But instead of me taking a decision like that, I thought, let me check with people. So instead of calling and asking for a survey, we created this system when in 10% of people were given a different shade. So 10 different shades of blue given to 10% people across the globe. And we were able to run the experiment for 2 weeks to find out which shade of blue gives us the best result. The shade we were using before that was kept at number 5. 9th darker shade gave us a higher return. 54% higher click-through rate. Wow, that was a lot. We changed the color in 2 days. Now, it does matter. I don't know why it matters, but yeah, psychologically or whatever you can call it. It does matter the layout. It does matter the user experience. All of them matters. If you give a better user experience, people will spend more time, people will do better. That's why companies offer millions and millions of dollars to data scientists who is actually able to run this experiment, design these experiments, and so on. So as a data scientist, one of your role would be always be to challenge, to be able to see what's happening in the industry and also see can something be applied. Okay, very, very interesting point we should probably keep. Okay. So let me take some more example. Okay. Now when you're doing a search, you see an advertisement. How do you decide which advertisement? So if you are a data scientist, somebody will ask you this question. So in a day in a life, you are asking your question for yourself that, hey, should I put this ad or that ad? Should I put Domino's ad or Pizza Hut ad or let's say McDonald's ad? Domino's is giving me 5 rupees, Pizza Hut is giving me 6 rupees, and McDonald's giving me 4 rupees. Obviously, we always will think, okay, fine, somebody who's giving the highest money, put that ad. But no, the revenue will come only when somebody click on the ad. If that is the case, then why should I put the random ad just for the price? I want to also look at the probability. So we came up with something, a combination of probability of click, the amount of money, and historical data of mine. And Mukesh has been shown the Domino's ad for last 5 times. So stop showing again Domino's ad to Mukesh. He will get fed up of this ad, show something different. So combination of that, 8 parameters were there by the way total. 8 parameters together gives us the final P click, which is if you show this ad, what will the probability somebody will click on it, and then it is higher. 44% higher click-through rate we were able to get just by doing this. Okay, so you can imagine how much data scientist is and can use in this area their ideas and thought process to be able to get more value for the clients. Okay, who's like for example, in the current day of Great Resignation, I build this system for multiple of my clients. Who is going to resign? Do we know that part? Can we build a model around that? Yes, it's possible to do that part. And we were able to pinpoint, these are the 4 reasons the person will leave. These are the 3 reasons which person will not leave. And if you do more for the people who will not leave, and if you do less of the people when they will leave, automatically the person will stay longer. Which video to show on the next? The whole data scientist will collect the data. 144 parameter, by the way. So the whole life cycle, which I'm going to talk about in a few minutes, the data scientists have to start with the idea first. Second, they will have to collect data. Third, apply some model, and then start doing the validation. And when they come to this point, right, they're going step by step to be able to see how am I getting to the real area where people will make decision on this. 144 parameter for a video. So when you watch a video, client doesn't know, the user doesn't know, YouTube doesn't know why are you watching. So it will look at the video, 145 parameter, apply the algorithms, recommendations, 7 different algorithms, get you the best options available, and then it will recommend what video should come in. Just about a year back, I was watching some old video, and it was a very old video, I think 30-year-old. I was getting nostalgic, so I wanted to watch that old video. I watched the video. After the video was over, automatically YouTube started playing another video from the same era. It was very interesting. I did not press the stop button. It continued for almost an hour, all the songs from that same era. Not the same author, not the same artist, not the same singer, not the same movie, same era. So all those things does matter. The data scientists who have written this algorithm would have been very happy because now that is driving more revenue for the organization. So data science is not just to write the algorithm and get the output, but also how it can improve the business, how we can improve the stickiness. Think about e-commerce. And you can put that in the chat window. I'm going to ask a question now. What is the probability? No, sorry, not probability. What percentage of sale on Amazon US website? What percentage of books sale on Amazon US website is because of recommendation engine? Books happen on Amazon. You go there, select a book, buy the book. What percentage of those sale is because of recommendation engine? If you can come up with some answer, that will be good. Okay. Yes, I got 2 answers. 60% Martin and Shailendra. Dennis 55%. Okay. 90% Michael, you're slightly higher side. Ian, okay. Okay. I think some of you know the answer already. Yes, the answer is between 60 to 70%. It is 65.1%. Yes, 65.1% of the books sale in US on Amazon site happen because of recommendation engine, which means 35% roughly happens because of a search. 35%, 65%, almost double. So you go there, search for one book, you end up buying 3 books. That's how powerful it is. No wonder Amazon pays millions of dollars to this data scientist to be able to write those algorithms so that they can make more value out of it. The recommendation engine. The financial transaction. Have you noticed when you swipe your credit card, sometimes the pay slip comes in 3 seconds. Sometimes it comes in 10 seconds. 3 seconds. Everything is good. Go ahead. 10 seconds. After 3 seconds, it realized that nope, I'm still not able to determine whether it's a fraudulent transaction or not. I need to run some more checks, some more probabilities, some more data science, some more machine learning model. It takes time. So yeah, it waits for 7 more seconds. 10 seconds is a timeout. So yes, it's good. You can clear the transaction or no, reject the transaction. Machine learning at best to detect financial fraud or even money laundering. Very, very interesting. I have written multiple money laundering, anti-money laundering algorithm in my previous jobs as well, in my current job as well. And very, very interesting to see people come up with so much of great ideas and patterns to do money laundering. And yes, systems can catch those patterns and alert the authorities for the same. Which movie to release? Of course, during pandemic was a challenge. Even now, it's a challenge in some countries. But yeah, I was able to build some model along with some of the data scientists working with me. And we were able to position for some of the top movie producers when to release the movie. And last but not the least, why are people leaving? So as a data scientist, your role will be to understand each of the element of what is required for you to get to the data and then take the decision, the business knowledge, all of those things together to be able to deliver, which I'm going to talk about in a few minutes now. Okay. Now, what you see on the screen is a combination. So data science is not just about one model, one data or so. You could be capturing data from hundreds of data sources. The highest model I created had 3,200 parameters. The longest model, the biggest, not the highest, biggest model which I created. So imagine so much of data coming in. We're able to crunch the data, find it out and everything. These are columns I'm talking about. Rows I'm not even counting. 10 million rows and all those things would be used to train the model. But it is possibility that, yeah, you could be looking at multiple parameters and some of the parameter does influence the output. So that's how you will build a model typically. So now you might be thinking about, okay, fine, this is all good. I understand, validate and all. How does it use in day in life? Like this. So a data scientist starts the flow with an idea. Now, some of the junior data scientists may not get idea. Some of them may not be allowed to work on the idea. But at a high level, it always starts with an idea. The crazy idea. The idea which you go, wow, nobody thought about that. Somebody who can come up with those will be required. The role which comes to the mind is product manager. The product manager somebody who comes up with the idea and works with the data science team to implement those ideas. Ideas need to be crazy. So people who regularly read articles and all come up with the idea. Then you need to collect data for the idea to build it. They build a model, try multiple models. When everything is okay, you deploy the model and then you monitor. Again, the cycle starts with the idea. The whole cycle is what a data scientist will look like. Let me drill down into an idea. What is an idea? Okay. So first and foremost part of idea is you need to know how things work. And this is the biggest area where a lot of people make mistakes. A lot of people miss out on how things work. Think about it. If you're into data science, this is a data hour, so you should all think about this question. Even if you're not in data science, ask a question for yourself. How does Google Map work? Now you have to answer, right? Why? How does Google know that after 1 hour, what will be the time, what will be the traffic and that location, especially if you are traveling for one place to other place that is taking more than an hour? How does Google know about all those? Okay, all these parts and part and parcel of machine learning. Okay, now coming up with the idea is important, but before that you should know how other things work, because now you are able to challenge the status quo. The important part, status quo. People say, yep, this is how it is done. But if you are coming with the idea, you should be ready to challenge those parts. Investigate, analyze, and provide your input that, yeah, this is how I want to work on. Now the idea part, sometimes people think, oh, anybody can come with the idea. Yes, anybody can come with the idea, but with the data science knowledge, your idea will be a lot more data powered, lot more authentic, lot more implementable, right? And of course, the idea doesn't have to always have to be data science oriented, but yes, here it is. It has to be something different. The something different part is an interesting one, wherein if you have a fear of failure, oh, what if something goes wrong? What will people tell me? If you have that fear, you will never be able to come up with new ideas itself. In fact, just a few days back, I was at one of the premium institute or management institute to interview, and I gave them a use case. Surprisingly, 7 people said we should not implement this. I said, why not? Oh, it's too risky. The risk appetite is very low for some of these people. But the other people say, yes, we should do it. Why not? Something different you should always there, and you have to ask question. I think the ask question part also is important. Ask question, challenge yourself, ask people question that, hey, if this something like this comes in, would you work on it? Would you take it? Very, very interesting part. And the new ideas. One of the phrase I remember is, a person with the idea, new idea is a crank until the idea succeeds. Why not, right? It's okay to be crank. But out of 10 ideas, if one idea works, it's great. And don't worry about 90% failure. Who is counting? Nobody's counting. Just focus on the idea which works for you. So as in the data scientist, a day in a life, I've seen people spending a lot less time on the idea. And that is why the biggest worry is. They spend a lot more time in data and everything because for practical reason, right? That's what challenge is. But spend more time on idea. You'll not regret. Now when I talk about data, what is data? The challenge with the data is sometimes it is structured, sometimes it is not structured. Data could be qualitative, data could be quantitative, all types. Keep your options open. Now think about it. When you finish your Zomato order, you get a message saying that the Zomato order was delivered. 1 to 10 rating you need to provide. We provide the rating and we sometimes provide the feedback also. And that's done. Rating, quantitative feedback. Text, qualitative feedback. A combination of that, structured and unstructured. 96.1% of the data in the world is unstructured. All your text, video, audio, images, and even some numbers are unstructured. So much of data is there. As a data scientist, in a day in a life, if you get a hold of some data, you need to either make them a little bit more structured or devise a way to handle the unstructured data as well. And that will be your goal, because you should always remember when you're collecting the data that don't just collect data of activities, even inactivity. Now, all of you, since 8:30 p.m. India time, you're not checking your WhatsApp. You are inactive on WhatsApp. People trying to reach you, they'll say, last seen 8:30 p.m. India time. That's your inactivity. Even that is generating your data. And that is important as a data scientist. You should know in a day in life that yes, you have to collect all types of data. You have value in each of the type. Because data tells a lot about somebody. It's an intent. Now, I'm going to ask you a question again. You can put in the chat window. What does 2020 mean to you all? 2020. Anybody? What does 2020 mean to you? Okay, I see some responses. Okay, match, year, eyesight, time. This is one of the few batch who did not use the word COVID. I like that. Okay, Usha, finally. Okay, fine. That's okay. Yes, 2020 is eyesight. 2020 is time. 2020 is year. 2020 is book by Dr. Abdul Kalam. And of course, pandemic, work from home, COVID, Corona, all those parts are there. 2020 is talk show in UK and 2020 is weight loss program in US. And there is a Parle biscuit in India named 2020 as well. If 2020 has so much meaning, how do you determine what people are really talking about when somebody says 2020? And of course, we all know it's cricket. 2020 has to be cricket as well. I'm not a big cricket fan, by the way. Yeah, I know you might be surprised by that. But when I type 2020, I don't get cricket score. 2020, I normally get something, either the talk show I'll get, or either the book by Dr. Abdul Kalam or something else. But my son, who's a big cricket fan, he always get 2020 when he types, he get cricket. Now imagine Google is tuned to that. Why you don't go and say, hey, for 2020, give me this. It just understands your pattern and say, hey, when Mukesh is searching, he's probably searching not cricket, something else, compared to when my son is searching. This important, as a data scientist, you need to be aware of that part, that when you're capturing the data, are you capturing everything correctly? And would that reflect an intent of somebody? And all this thing what you're capturing, it has to tie back to the dollar figure or the rupee symbol, because otherwise it's all wasted. So whatever you do has to tie back to the results. Now comes the interesting part, building a model. I often get requests. See, I also coach several professionals, senior people, right? People with 12 plus years experience, people, I coach them in their career, 1 month, 2 month thing. And this is the question I always get from them. Can you give me a cheat sheet for what problem, what model to be used? And I said, I have the cheat sheet, but I will not give you. Try multiple models. Now imagine if I give the cheat sheet, what will happen? Oh, these problem, okay, fine, these model. Yes, you apply that, you got the output and you're done. Where is your learning? Where is your research? Limited. Now, same thing if you do it, take the data, apply 7 different models, 2 models gives you good output, you move ahead, but you document that all the 7 models and some slide. Tomorrow when you show this to me, and I say, hey, you should have done the other model. Oh, we tried, it did not work. We should have done that model. We tried, it did not work. I will not trust you after some time. But as soon as you say, yeah, we tried, we did not work. By the way, it's in the appendix. And you go to appendix and say, hey, these are the 7 models we tried. 5 of them did not work, 2 of them work. I say, wow, I will trust you a lot more going forward, because now I know that if you are doing it, you will have documented that. The try multiple model is important. Running with the sample data, and then you investigate, analyze why certain things work, did not work over a period of time. See, I've been doing data science for 23 years now. Data science, artificial intelligence, machine learning. If you give me a problem, I can even tell you which model will work, whether it will give the output or not, what false positive, false negative challenges you're going to get. I'll be able to tell you that. But if you want that shortcut, it will be challenged because your learning will be limited. The shortcut is not what I read from a book. The shortcut is based on my real life experience doing thousands of projects so far in my career. How do you monitor quality? Is it the accuracy you're going to focus on? Is it going to be F1 score? Precision, recall, false positive, false negative? All these questions you have to ask yourself. Because if you ask questions, then you check, otherwise you will not get output. And finally, you capture the output and then say, yes, this was the output from the model, and we move forward. Because after 5 days, after 10 days, you'll forget what the output was. And do not rely completely on Jupyter Notebook to run all the time for you. So you capture the output, put it into your Word document or a PowerPoint, and you're done with it. And publish it, of course. And last point before you go to monitoring is your deployment. Now, the deploy part is a challenging part. Some of you may have heard about ML Ops, machine learning operations. It's a variant of DevOps, development operations. The important part to notice is ML Ops is required at very simple steps. Few hours and you are done with ML Ops. So the main element of ML Ops is how do you integrate with the data, how the output comes out. Because when you're running the model, normally all of you would have done, if you have built a machine learning model in Jupyter Notebook, you would have done it on your computer. Everything works perfect. But that's not the real life. The real life is the server somewhere in the cloud will be running. You will not have user experience. You will not see the UI. You call an API or call a URL and you get an output. That's it. And how do you get it? You cannot run Jupyter Notebook. So you have to make it easier for input and output processing on ML, and that's why it takes slightly longer. And then you do the pilot or the test run, whether people have access or not. When we give the input, we get the output and everything and all. You do this part, you get the insights, and then yes, is ready. You test and validate. Why is testing and validate is separate? Testing, you input, you getting output. Yes, input is this, output is this, right? And all. But validate, is this really solving the business problem? Where it starts with, okay? You might have also heard about the term verification and validation. Right thing, doing right thing, validating right thing, you do all of those things, and finally say, yes, now you're going to report it. That yes, it is ready and people can use it. The whole deployment element, sometimes it is misunderstood, sometimes it is given to MLOps, data scientists don't get involved. I encourage strongly, at least for first 2 to 3 projects, you should get into deployment as a data scientist. Few more slides and we'll open up for questions. Monitor. After you deploy, what do you do? Oftentimes, I've seen people forget about the models. Sometimes models stop working. Who is checking that? Sometimes model developed a drift. Drift is the most common problem, by the way. Drift. Your model output is this, and the actuals are higher than that or lower than that. Continuous delta in one way or the other, positive or negative, over a period of time is considered drift. And it increasing over a period of time. Even if it's like off by, let's say, 2% up, continuously, it's still called drift because the thing have changed. You need to retrain the model and align it. There are multiple models available, but you need to monitor to see whether there's a drift or not. 1, 2, 3 data point outside doesn't mean that there's a drift. But if you see a consistent pattern, if you're moving something data in one direction or the other direction, you call it drift and then you prevent it from happening. Bias. Most horrible part, most horrifying part. Multiple examples. ICICI. There was a case reported in the newspaper wherein somebody created the model for loan defaulters. And then next time when somebody was applying for loan, and they will detect and then they will reject the application based on certain parameter. Surprisingly, one of the parameter was Skoda car. If you have a Skoda car, there's a high chance you will be rejected. Why? Because the model was created, they captured the data, and then one of the data was, what car model do you have? And people had Skoda car model, and the model was incorrectly trained. Bias. Similar bias was detected at Amazon site. This is again available on the internet website news, wherein Amazon invariably were rejecting all the female employees who were applying. Why? Because the model they created was based on some of the star performer within Amazon, and they gathered their resume, trained the model. They forgot to remove the gender from the list, and the gender was also one of the parameters. And they found out that most of the people were male, and the model was biased towards male and against towards female. Bias. Very wrong thing. You could get into trouble legally also if your model has a bias. So you have to be tested a lot more. GDPR compliance requires you to take care of bias as well. Performance of the model, right? Is it leaking memory? Is it working fine? Is it storing well? Does it having a lot of errors, error timeouts, all those part? And do you need to optimize? How much the server usage? You might have given a much bigger server. You might have used a GPU. You might have used a very small server. Do you need to optimize the server utilization so they optimize the cost? And then what is the right time for retraining? People ask me this question, what is the right time to retrain? I said you should retrain every day. No, not required, right? You have to train the model as soon as you get the drift. You need to train the model at the right time. I normally encourage people, if there are major change in the way things are working, you should train the model. Training the model once a year is definitely too long. Training the model every day is too fast. Once in a month is the most ideal part, I would suggest. So in conclusion, the sexiest job of 21st century, yes, 10 years back it was mentioned, and it is true. $500 billion economy, 2 years back it was mentioned, 2.5 years back. I think we are already $500 billion economy. More and more people are getting into data science now. The industry is expecting, can you look at the data, artificial intelligence, and get business value? So the day in life which I talked about, when you get interviewed, when you are preparing for this, make sure you talk about what all things, elements are required to be able to finish a data scientist job. Okay, and then how are people can leverage the power of data and then use the technique which I talked about today, some of them. Your ability to explain, ability to come up with idea, all of those will be tested in your interviews. One other thing which I like the phrase, which is jack of all trade, master of some, which means you know a lot of things, you are specialized in one area, that will be appreciated by a lot of people. If you look at all the top 30 technologies, artificial intelligence, Internet of Things, those are some of the top ones in the industry right now. And then of course, blockchain data, big data is also there. So you probably are getting into the right zone if you're getting into this. And last slide, talking about future of data. I think more and more people will focus on the data literacy. What I mean by data literacy is, do you understand the data? Can you read and write data? Those kind of basics part. Because people are not going to be, a lot more going to be collaborative intelligence now. You need to have more people working, more people coming up with the idea and then doing it with you. And the data is going to commoditize big time. What do you mean by commoditize? Commoditize means it will be easier. You can purchase them in small bits and pieces and it will work for you. Proactive, prescriptive, predictive, augmented analytics will be key in this area going forward. And analytic as a service, insights as a service will become more and more popular. So as a service model will be implemented here. Tighter intelligent integration between human and machine you will see those part. And then of course, sustainability, ethics, responsible artificial intelligence, explainability part, all of those things are becoming more and more important. You may not have learned about all those parts, but before you deploy a model and all, some of this has to be explained. Sustainability is very interesting part, because every time you run a model, every time you are building a model, training a model, you consume a lot of compute that have a sustainability effect. How do you minimize those parts? And of course, data scientist, chief data officer, all those things are becoming new roles people are getting into. So in closing, my learning has been in the last 30 plus years, try, पूछने में क्या जाता है? In English, there is no harm in asking. This is something which always excites me, because sometimes you get high success. My job at Microsoft was one of these reasons. A person with the idea is crying until the idea succeeds. I can tell you, I might have come up with thousands of ideas, but it doesn't matter to me. But those 20, 30 ideas which have worked successfully, be it at Microsoft, be it at Capgemini, be it anywhere else, I think that is one of the things which is the most part which I cherish. Action without results is noise. Remember those points. You have to also demonstrate results. If somebody can find mistake, why can't you yourself find it? It's an important part to validate with you. Focus on the knowledge. Okay, the things success will follow automatically. Your Shubchintak or well-wisher will be the one who will be giving you good advice. Estimate, do whatever you do, right? If you start becoming a person who is always estimating, who is always doing what they say, is always a good place to be in. There's learning everywhere, by the way. And the 9th point is, do what you enjoy. One thing I found out, if I think after the last 26 years which I've been working, 27 years, maybe there were 6 months which I did not enjoy, but every time I was enjoying it, which means I was doing my hobby and I was getting paid for that, and give back time to community. This is how I give back time to the community. With that, I'm going to pause and I'm going to take questions. I know some of you have put some questions already. We do have some time to take questions, so I'm going to take each of the questions.
Excuse me, sir.
Yeah, go ahead.
Sir, before we going to answer the question, please, I would like to request all the attendees to kindly fill the poll about feedback, as it helps us to connect more such sessions. Thank you, sir.
Okay. I see one question, which is, was it always called data science? The answer is no. It was never called data science. It was actually called data analysis, not even analytics. Okay. I remember my days when I wrote my first machine learning algorithm in the year 1999. It was written in C language, 221 lines of code. And it was not even called data science. So yes, data science is a new word. Mostly it started getting used around 10 years back. Were results good with limited data point back then? Dennis, the results, I would say it is better than nothing. Data was limited. Data was always limited, and it will always be limited. So do not worry on the volume of the data. It was about, if you get them data, you start with something, accuracy. Even if you get anything 70% or higher, it is a good start. The challenge we normally take is the expectation is very high. It should be 90% accuracy and all those parts. Not necessary. But think about it. As a human, if you're able to do better accuracy, train the model. The thing which I always tell people, if the accuracy is low, which means you have forgotten, you have not put all the data points. The example I'll give you, if some of you are following cricket, you would know the example. Then I'll give a translated example into a simple one. One of the cricket player in India, Virat Kohli. If I ask you this question, how much score he's going to make when he's playing today, whenever he's playing, okay? And I get people say 1, 2, 3, 4, 5 parameter max. But if I start writing, I can at least find out 30 parameters I can find out easily. Plus one more parameter. Is his wife, Anushka Sharma, is she there in the stadium or not? Does that matter? Maybe. And I put that part. And yes, the answer is yeah, it does matter. Okay. So now, translating that into the data science problem, you don't know what will matter, what will not matter. But the more data you capture, the high chance of you getting the answer. So it's more columns that are more important than more rows. But yes, prediction is a challenge. But then if you get some good data point, you will be able to predict. Start with this. And wherever your prediction went wrong, capture why it went wrong. And then you will get a better accuracy going forward anyways. Okay. Another question I see is, how would advise understanding and improving the one knowledge on model deployment, data modeling? What is the best practice in this area? So, see, there is no best practice. Normally, it is always about whatever you do. Normally, let's say you try something, and if it doesn't work, you just delete and you try something else, and then it works, and then you forget about what you deleted. That is something which I strongly recommend not to do. You get some output, you don't like it, fine. Add another code, and finally, when you like the answer, go back and write it down. This I tried, it did not work. This I tried, it did not work. This is what happened and all. And that becomes your running document, your running learning. And publish that in with the output also. Hey, by the way, to get to this point, I tried 7 models. 5 of them did not work. This was the reason. And now this is the reason it's working. So that way, people will trust your output a lot more. What is difference between operational research and data science? This is very good question. By the way, operational research in the olden days, that was the only branch that was dealing with data. Yes, there were statistics, there were probability, but this in engineering, operational research was the only branch we were dealing with data. But the data science part, if some of you may even ask the Six Sigma part also, right? The data science part is the one wherein it actually looks at data from multiple angles and then try to bring in the analytics, the machine learning part and all. All of them may not be part of operational research in the original context. So I would say, yes, if you know operational research, your data science will be a lot more easier for you to do if you're done hands-on programming. Operational research, as my understanding during my time, the programming was not part of it. So if it's not part of it, then you have big knowledge anyways. What is difference between data analysis and data science? Very good question again. Data analyst is somebody who is dealing with data. Your SQL, your data cleaning, your missing value imputation, your massaging the data, extracting some key information, writing the Excel formulas is your data analyst job. Building model, running machine learning part, and output, looking at the insights, forecasting, publishing the report. That is your data science job. So data analysts sometimes also publish report, just the basics of data, insights of data, but not more than that. What is the advice for you when you're striving to become a data scientist? So Dhanush, the answer is, if you want to become a data scientist, once you go through the course and everything, be curious and try with more data. Try with data across the globe. Everywhere is use data. In your current company, there is data. On Kaggle, there is data. If you just search for random data, you will get data everywhere. Get the data, build a model, and get some insights. You'll be surprised how much insight you can get with a very small set of data also. Okay. So definitely you can do this part. There's a lot of learning material available online as well. How much DSA knowledge is required for data science? So Siddharth, a very good question. Data DSA, I believe you're talking about data structures and algorithms is required for data science. Siddharth, the answer is not as much. Okay. Yes, if you have some data structure and algorithms knowledge, it will be helpful, especially if you're going hardcore programming, the deep part of data science. Yes, it will be required, but not much is expected as a basic starter point. Now, you also ask yourself, are you going to go for a pure data scientist job? Or are you going to be like a more data science lead? Are you going to be the manager part of it and all? If you want to write the optimized algorithm with the minimum number of steps and everything, data structures and algorithm will work. Remember, if you are going for a job at Microsoft, Uber, Google, Amazon, Facebook, Tesla, you better know data structures and algorithm. Otherwise, forget about the jobs, right? In this company. Because that is a place where everything you write, anything you write, it need to be optimized seriously, because you're talking about millions of people using it. So even slightest more non-optimized code, it is more damaging to the company. If the columns are more want it overfit, no, that is the misunderstanding a lot of people have. It will not, and you will know if it overfits. You have to create the model, and then you look at it, validate it. If it overfits, you need to optimize it. There's nothing called columns are more, it will overfit. As I mentioned, 3,200 was the highest number of columns which I have dealt with, and this is the beginning. By the time the model was created and everything, 221 was the line. No, so 221 was line of code. 241 was the number of columns which was in the final model which was deployed. So yes, it's not about that, but if it is required, it is required. As long as it is improving the quality, why not? How can I learn about model deployment and monitoring? Model deployment and monitoring, there's not enough material available on the internet, but yeah, if you search, you might get some of them. But my experience has been, if you start doing it, preferably in your own organization, this will come naturally. Because deployment, you can still do it on your own, some for random website, a random algorithm and all. But monitoring comes when it is dealing with real data. Okay, you cannot just monitor something which is created randomly, because if it will just work with the random data, you will not even know whether it's right or wrong. How long does it take to complete an end-to-end machine learning project? Chukvuka, I think this machine learning project, some cases it might take even 6 months. Some cases it could be take much longer than that. My experience is, for any project in my team, because I'm a Chief Technology and Innovation Officer, I want to make sure innovation is happening at a faster pace. I make sure it is done in 3 weeks. You do something in 3 weeks, release it, you can improvise next version after 3 weeks, another 3 weeks, next version, another 3 weeks. But normally, because it's 3 weeks, people have to show some output. I'm able to get some good output in 3 weeks only. 3 weeks is a psychological number, because as soon as you say 4 weeks, people think it's 1 month, and 1 month is okay, not bad. 2 weeks is little too hasty. So 3 weeks is what I normally encourage people to do for end-to-end project. Ganeshan, inspirational session attended so far. Kindly forgive me for posting in Q&A, no problem. Thank you for that comment, Ganeshan. You search for my profile, did not able to find out. Okay, just search for Mukesh Jain, CTIO Capgemini, or Mukesh Jain Capgemini. You will see my profile on LinkedIn. Difference between data science lead, data science specialist, data science consultant, and senior data scientist. See, all these roles, if you see, the titles could be anything. Okay, but you have to make sure you understand what is the expectation. The years of experience would differ. So if you are a data scientist, probably it will be maybe the associate data scientist, data scientist could be at least jobs, and senior data scientist will be after that. Data science specialist will be after that. then you become a data science consultant, and then you become data science lead. This is my understanding of the growth and so on, but some organization may have slightly differently. Becoming a data science lead is a really good place to be in, because you are now able to manage a team of data scientists, and then you are able to guide them very well. How do you perform feature selection with thousands of columns? See, that is a good question. So I have to ask lots of people to do, hey, 1 to 500 you are doing, 500 to 1000 you are doing, 1500 you are doing, and people will do it, and they have to come back with justification of what are the 1, 2, 3, 4 features they would like to recommend, and then let other people debate and so on and so forth. It was a proper project. I think the project lasted for 5 months. I did that in 5 months. Yeah. So it took some time. So yeah, spending time on each of the column, understanding those parts. Some of them were automated to be able to find out. Some of them were deleted during my EDA, exploratory data analysis. I was able to delete some of them. Can please tell me how much Python is needed for data science job? Bala, you need lots of Python, yes, for data science job. Is Python, see, Python, there's a story behind Python, by the way. So our language was the original one for data science. That was because data science was considered statistics. Okay, R was developed by statisticians. So they use R for quite some time. Just about, when was it? 6 years back, Python started becoming popular. But Python was developed by engineers, saying that there are non-engineers, non-programmer who want to write program can use Python. It's simpler. So if you are using Python, you are already using simplest programming language. In fact, I had to force my son not to learn Python. Why? Because he's becoming engineer. I said, hey, you're becoming engineer, you focus on C, C++, and not Python for now. So if you are already finished your engineering or what, your graduation, whatever, and if you are getting into this data science, learn Python. Python is very, very simple. I can give you some tips about how to learn Python faster, but learn Python. And I teach Python to commerce students. I teach Python to art students. And in less than a month, they're good. They may not be good programmers. They don't want to be good programmer. You are becoming data science part. So focus on those pieces as well. So I think it's required to do that. Make sure you learn those part. Is OOPS required? Yes and no. OOPS stand for object-oriented programming. No, it is not required for data science. If you do it, good, but not required. But if you're going for Microsoft, Google, Amazon type of job, yes, it is required there. Is variance and noise the same? Dhanush, definitely not. Variance is something wherein the data is variation up and down and everything. Noise is something which is not part of the signal, which means the actual value was this, but value was slightly higher or lower because of noise. So the actual value can have variance. Noise can be on top of it, which is somehow by mistake added because of some wrong things which are happening nearby. What is FMing expect? What the FAM from data science candidate kindly share views. So Pooja, FMANG, I believe you are referring to a company in US. So I already talked about some of the elements that they would expect you to know the basics of data science. Always remember there are 3 types of questions they will ask you. Basics of data science, which is bottom up. Can you understand model? Do you understand basic coding? Do you understand how to do missing value imputation? Basic. That's the first part. Depending on the company, they will spend more time on basic. Microsoft, Google, and some of these product companies like FMANG and all those, they will definitely look for some of the basics. Is your basic good? Is your basic strong? If not, then they will not even select. Second, top down. So for senior role, top down is more important, wherein they say, hey, this is the problem. Uber is having problem in this city. How are you going to solve this with data? They'll expect you to think about, I'll use this algorithm, that algorithm, and all those parts to get the output. And the third one, once you have it, once you deploy, how are you going to monitor? How are you going to make sure people are aware of it? How are you going to make people adopt that? So all these workshops I conduct, right, with the university, 2 days, 4 days lectures I conduct on data science, we cover those in detail about how do you prepare yourself to crack the interviews as well. Okay, please differentiate data science and AI. Okay, data science and AI. So it's a very question, I get this question very regularly. I would say data science is a much bigger umbrella, includes anything and everything to do with data. Artificial intelligence is just another point like that. That's how I would normally look at it. If you are done with data science, you know data, you know machine learning, you know how to implement and so on. If you want to learn artificial intelligence, yes, you can do that as well. There are expert systems, there are neural network. There are lots of things to deep learning. You have to learn reinforcement learning. So many things to learn, right? Some people consider all of them as part of data science. Some people consider data science as part of artificial intelligence. This is still debatable whether what is right or wrong. It doesn't matter. For me, data science encompasses everything. But if you say you are data scientist, the first thing people will ask, first thing I will ask, data scientist in what? And then you say, okay, I've done this part. Okay, fine. This areas of data science. Like a computer engineer. Computer engineer is a computer engineer. Doesn't mean that they know everything about computers and all. Like they may or may not know hardware. They may or may not know certain technology. They may or may not know cloud. It's like that. Last few questions. I'm already out of time, but I'll take some more questions. How do you prepare for first few interviews? Because usually the certification and capstone project, we may get some knowledge, but actual expectation is real work. See, Chetan Rao, this will be true for life. You're going to the training, people will expect work, and you don't have work. That is the fact of the life. Work experience. You don't have work experience, that's a fact of the life. So don't worry about it. Do not think negative about it. If you think negative about it, it will be negative for you. Instead, say that, yes, I just finished the course. I've done some POC in my current organization. It is not deployed yet because we are still in the early stage. And I did not get time to get the real life experience. I'm hoping to get it from you, but I know what I will be doing when I get there. Show that confidence that you understand this part. But if you reject yourself, then nobody will help you. Let others reject you. Okay. Next question, Siddharth. 1 to 500 column, do your subordinates perform correlation? You are really getting into details, Siddharth. Huh? Yes. So the correlation can happen from one column, from this part, one column, but that would be done at the all aggregate level. When I'm asking my subordinate to look at it 1 to 500 columns and all, I'm out to actually understand that, do you understand each of the column? And is there something I need to treat some columns specially? But if I want to do cross correlation, multi-collinearity and everything, I'll use all the 3,200 data sources, columns. What certificate do you recommend for data scientists to acquire? Martin, there are lots of courses which goes through that. I would suggest to go through some of the course and get those certification. Majority of the courses will have similar content, few algorithm here and then, that's it. Any course is good. But more than the course, the practice is more important. Once you do the course, if you don't practice, you're as good as not done, because this is part-time course. Imagine there are, for example, BITS Pilani have these masters. I was a contributor there to build that curriculum for them. So many institutes, I've launched data science 4 years degree. They take 4 years full time to finish the degree. And here we are doing it part-time for a few months. It's not equivalent, right? So practice, practice, practice. It is more important for practice there. Learning Python faster. Ernest, everything you want faster, huh? Good. There are some tips, right? So in Python, one of the things which I always do is open Excel. Whatever you do in Excel, and I'm sure you do Excel a lot. All of you do Excel a lot. Do it whatever you're doing. Table, sort, reverse sort, pivot table, formulas. Spend 5 minutes, finish it with your favorite data source. Exactly those things you need to next do it in your Python. So you have something in front of you, you are doing it in Python. Rinse and repeat, rinse and repeat, and rinse and repeat. It should be at some point, should be able to say, hey, I no longer need Excel. I can use Python to get the same pivot table which I create in Excel. Probably less time than that. Initially, it will take longer time, by the way. You do this couple of times. That is one part of it. Second part, Python, it's, if you look at it, right, the whole code which I wrote in 221 lines in my early code in C language, in Python, I could have written in 5 lines. And the biggest challenge when I was learning Python was, I learned Python 6 years back. I write 1 line of code, 2 lines of code, and I say, done. That's it. In the C language, I would have written 20 lines of code. So that is a good and bad part about Python. So for you, if you're learning Python and all, I would suggest refer to some of the books are available, programming in Python and all. Do line by line, word by word. But that is only when you do a lot more practice, you will be able to get confident. Okay, I was able to, okay, one more question. Fine, Ramakant. Is it possible to do career transition after working in different domain for more than 10 years, become a scientist? So Ramakant, that is, I would say, wrong thinking. Do not think about transition. Think about plus plus. What does plus plus mean? So you have 10 years experience, that's your asset. Do not let go of your asset. That's your asset. Get a job in those assets, but ask them that I want to do data science. I will, on top of it, I'll add data science also. Okay. And they'll be a lot more open to do that. Now think about it. In your 10 years experience, you have done dealing with client, you have done how to build a team, you have done how to do technology, you have to do stakeholder management, communication, project management. You've done so many things. Now, if you are a project manager, become project manager of a data science projects. If you come to data scientist, you come to me, Mukesh, I want data scientist job. I say, okay, fine. I'll give you salary of 7 lakh rupees. They say, why 7 lakhs? Yes, 7 lakhs. 1 year the experience I'm giving you. But you say, no, I have 10 year experience. But are you going to use the 10 year experience? And the answer is no. So that's why do not go in that direction. I would suggest do not lose out on your asset. I keep seeing people asking, what is the important topic for fresher to clear interviews and get the first job? Kiran, normally freshers will get the placements in their college. I would encourage you to clear there and there itself. In India, for whatever reason, majority of the company do not take fresher directly from the market. That is true right now. But yeah, if you go jump to startups and all, you might be lucky to get those jobs directly. Otherwise, it's hard to get a job because every company will go for placements only. So that's the reason I would not encourage you to try outside, Kiran. But if you really want, make sure you highlight your success and everything on LinkedIn. Make sure you participate in competition on Kaggle. Make your profile look stronger. In your resume, you should mention that you are a topper in this, topper in that. You've done this data science course. You are 4th ranker in this, 6th ranker here. Here is my GitHub profile. Then you might be able to excite some people to get a job there. Otherwise, getting a fresher job in India is difficult if you're not done through placement. Okay, I know, guys. Sorry, I took longer than I thought. The questions kept coming, and I thought I didn't feel like stopping there. Over to you, moderator. It's 10 minutes over already.
Thanks a lot, sir. On behalf of Analytic Vidhya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in future. Thank you so much, sir.
Thank you all. All the best, and hopefully looking forward for another session interaction with you. Thank you. Take care. Bye.